Okay, suppose you roll a sum of 8 on the first roll. Find the probability that you subsequently win the game given that you rolled an 8 to start with. This is problem number 7 from station number 2, Craps. And to solve this problem, there's some information you need. So let me go through and help you understand that information. Let's look at this graphic that I have here. So to understand the question, we're assuming in the first place that you rolled an 8 on the first roll. So what are the things that can happen? Well, number one, you get to roll again. And on the second roll, you will lose if you roll a 7. And the probability that you will roll a 7 is the probability that you will roll a 7 is 6 over 36 because there are 6 different ways to roll a 7. Um, 2 and 5, 5 and 2, 1 and 6, 6 and 1, 3 and 4, and 4 and 3. Or you could win by rolling an 8, and there are 5 different ways to roll an 8. So that probability is 5 over 36. Or you could roll something other than a 7 or 8, and that probability is what 36 minus 11, which is 25 over 36. So if you roll an 8, then you win. So the probability that you win would be 5 over 36, but this is only the probability that you win in your second toss of the dice. What could also happen is that you roll again. And if you roll again, then there are 3 more things that could happen because the rules don't change. If you roll a 7, you lose, and that probability is still 6 over 36. If you roll an 8, you win, and that probability is 5 over 36. Or you can roll something other than that, and that probability is a 25 over 36. So if you win in the third probability, then it would be 5 over 36 plus to get to this third throw, you have to roll other. Probability of rolling other is 25 over 36 times the probability of rolling an 8 and winning is 5 over 36. But these aren't the only ways to win because it's possible in this third roll of the dice that you roll some number other than a 7 or 8 and you can then roll again. So you still have a chance to win, and your chance to win, again, a probability of 7, probability of 8, probability of other. And so the probability of winning the third time, you have to roll other twice. Excuse me. That's supposed to be squared. This is not a plus sign. It's a mistake. Times the probability that in the fourth roll, you roll 5 out of 36. That you roll an 8 is 5 out of 36. So hopefully you're observing the pattern here. And let's go and let's show one more case of this. You could also roll a other. So if you roll a other, you'd have to roll a other the second time, roll other the third time, roll other the fourth time, and then roll 8 the fifth time. And the probability of, again, of rolling the 8 doesn't change. It's still 5 out of 36. So what we would need to add to all these different probabilities of winning is you'd have to roll something else 3 times, something other than a 7 or 8 3 times, and then in that last roll you'd have to get 5. Well, this could go on and on like this forever. Theoretically, which means that we would have to add a large number of probabilities of. This kind of sequence is called a geometric sequence. It's a geometric sequence because each term I'm multiplying by the same thing. So the common ratio that I'm multiplying here is 25 over 36 for each term. So it's 25 over 36 here. I'm multiplying by another 25 over 36 there. I'm multiplying by another 25 over 36 there. And the number that I'm starting with is, I keep using that 5 over 36 over and over again. So this is called a geometric sequence. And a geometric sequence, just in general form, a sub 1, our a sub 1 is 5 over 36. And our common ratio, is 25 out of 36. And the formula for this. So if you're trying to find the sum of an infinite geometric series, then it's given by this formula. It would be a sub 1 over 1 minus r. So in our case, our a sub 1 is 5 over 36, and our r is 25 over 36. So you just need to go 1 minus 25 over 36. So this answer gives you the answer to number 7. So I'll leave the arithmetic in this problem to you.